What if Earth is not the only habitable planet in the universe? Scientists have searched for distant worlds beyond our solar system for decades. The search focuses on planets that might support life conditions similar Earth. Such planets are called potentially habitable worlds in modern astronomy studies. Distance from a star determines temperature and possible liquid water existence. Liquid water is considered an essential ingredient for life as we know. Planets too close to stars become extremely hot and unstable environments. Planets too far away freeze into icy, lifeless frozen worlds. The habitable zone is a region where conditions may support life. This zone is sometimes called the Goldilocks region by scientists. Atmosphere plays a critical role in protecting life from harmful radiation. Without atmosphere, planets cannot retain heat or support stable life. Carbon dioxide levels also influence planetary temperature and climate balance. Gravity must be strong enough to hold atmosphere effectively. Magnetic fields protect planets from solar wind and cosmic radiation. Without magnetic protection, atmosphere can slowly be stripped away. Planet size influences its ability to maintain long-term habitability. Earth remains best known example of a life-supporting planet. Mars once had rivers but lost most of its atmosphere. Venus shows runaway greenhouse effect, making surface extremely hot today. Studying other planets helps understand Earth's own delicate balance system. Telescopes like Kepler and James Webb discover distant exoplanets daily. Exoplanets are planets orbiting stars beyond our solar system. Some exoplanets may have oceans hidden beneath thick cloud layers. Scientists analyze light spectra to detect water and gases. Oxygen presence could indicate biological activity on distant worlds. However, oxygen alone does not guarantee existence of life. Life requires stable environment over millions or billions years. Tidal forces from nearby stars may disrupt planetary stability. Gas giants are usually unsuitable for Earth-like life. But moons around gas giants could potentially support life. Europa and Enceladus are icy moons with hidden oceans. These oceans might contain conditions suitable for microbial organisms. Temperature stability is a key factor for sustaining complex life. Planets with extreme weather may struggle to support organisms. Stable star radiation is essential for long-term survival. Red dwarf stars may host many potentially habitable planets. However, these stars can produce dangerous solar flares frequently. Distance and orbital stability determine long-term habitability chances. Astronomers use advanced technology to map potential habitable zones. Future missions aim to explore exoplanets more directly soon. Space agencies are developing powerful telescopes for deeper observation. James Webb Telescope reveals unprecedented details of distant planets. Data from space missions constantly reshapes our understanding of habitability. New discoveries suggest planets may be more common than expected. Milky Way galaxy likely contains billions of potentially habitable worlds. Finding life beyond Earth remains one of humanity's biggest goals. Such discovery would change science and philosophy forever completely. Scientists continue searching patiently for signs of extraterrestrial life. Technology improvements increase chances of finding habitable planets quickly. Every discovery brings humanity closer to answering life existence question. Understanding habitability helps us protect Earth more effectively today. Earth remains fragile and requires careful environmental balance maintenance. Studying other worlds teaches valuable lessons about planetary survival. The search for life continues across endless cosmic distances. Each discovery fuels curiosity about universe and existence itself. Habitable planet research is one of astronomy's fastest-growing fields. Future generations may witness discovery of another living world. Such moment would redefine humanity, place and universe completely. Until then, exploration continues with hope and strong determination. Every telescope brings us closer to cosmic understanding daily. Mystery of life beyond Earth remains unsolved, fascinating question. Science continues pushing boundaries of space exploration further outward. The universe holds countless secrets waiting for discovery still. Our journey to find habitable worlds has only begun. Astronomers now focus on detecting Earth-like planets outside the solar system. These distant worlds are called exoplanets in modern space science. Most exoplanets are discovered using the transit method of observation. This method detects small dips in star brightness during planet passage. Even tiny changes can reveal presence of a distant planet. NASA's Kepler mission revolutionized exoplanet discovery over the past decade. Kepler identified thousands of potential planetary candidates across the galaxy. Some of these planets lie within habitable temperature zones. Scientists carefully analyze which ones might support liquid water. Liquid water remains the primary requirement for known biological life. Spectroscopy helps detect chemical composition of distant planetary atmospheres. This technique breaks starlight into detailed chemical signatures. Carbon dioxide, methane, and oxygen are key atmospheric indicators. Presence of methane may suggest biological or geological activity. However, interpretation of these gases remains scientifically challenging. False positives can occur due to non-biological processes. Researchers combine multiple data sources to confirm habitability potential. Planetary density helps determine whether a world is rocky. Rocky planets are more likely to support Earth-like conditions. Gas giants lack solid surfaces for traditional life forms, but their moons may provide alternative environments for life. Europa's icy surface hides a vast subsurface ocean below. This ocean may contain energy sources for microbial organisms. Enceladus also ejects water vapor from its icy surface. These plumes suggest possible hydrothermal activity beneath the surface. Hydrothermal vents on Earth support life without sunlight energy. This increases the possibility of similar life elsewhere in the universe. Distance from star determines surface temperature stability greatly. Orbital eccentricity also affects seasonal climate variations significantly. Stable orbits allow long-term development of life systems. Rapid climate changes may prevent biological evolution processes. Planetary rotation speed influences atmospheric circulation and weather patterns. Faster rotation creates stronger winds and extreme climate systems. Tilt angle determines seasonal variations on planetary surfaces. Earth's stable tilt supports relatively balanced seasonal climate. Without stability, planets may experience chaotic environmental conditions. Red dwarf stars are common in the Milky Way galaxy. Many potentially habitable planets orbit these small stars. However, stellar flares can strip planetary atmospheres over time. Scientists still debate habitability around such active stars. Super-Earths are larger rocky planets discovered recently. These planets may have stronger gravity than Earth. Strong gravity could affect atmosphere density and composition. Some super-Earths may support thick protective atmospheres. Thick atmospheres could help retain heat for life. Researchers simulate planetary conditions using advanced computer models. These models predict climate behavior under different scenarios. Space telescopes continue improving detection accuracy every year. Future missions aim to directly image Earth like planets. Direct imaging will allow better study of atmospheres. This advancement could confirm signs of alien life soon. Finding biosignatures remains top priority in space exploration. Biosignatures include gases linked to biological processes on Earth. Scientists remain cautious when interpreting potential life signals. Confirmation requires repeated observations and strong scientific evidence. Each discovery refines understanding of planetary habitability conditions. The universe may contain countless life-supporting environments. Humanity continues searching with advanced technology and hope. Every new planet discovered expands scientific knowledge further. These discoveries reshape our understanding of cosmic possibilities. The quest for life remains an ongoing global scientific effort. International collaboration strengthens research and exploration missions worldwide. Space agencies share data to improve discovery accuracy. The search for habitable planets continues with determination. Scientists believe discovery of life may happen soon. Beyond detection methods, scientists study planetary chemistry for life clues. Chemical balance determines whether environments can sustain biological processes. Life, as we know, depends on stable chemical reactions. Water acts as universal solvent for biological molecules on Earth. Without water, complex organic chemistry becomes extremely difficult to sustain. Carbon-based chemistry is foundation of all known living organisms. Scientists assume carbon may also dominate extraterrestrial life forms. However, alternative biochemistries remain possible under unknown conditions. Temperature range is a critical factor for chemical stability and reactions. Extreme heat can break down essential biological molecules rapidly. Extreme cold slows chemical reactions to near-complete inactivity. Stable moderate temperatures increase chance of biological development. Planetary atmospheres regulate surface temperature through greenhouse effects. Too strong greenhouse effect can make planets uninhabitable quickly. Too weak atmosphere leads to frozen and barren surfaces. Earth maintains perfect balance between heating and cooling systems. This balance took billions of years to stabilize naturally. Plate tectonics also plays role in maintaining habitability conditions. Movement of crust recycles carbon and stabilizes climate systems. Without tectonics, planets may lose long-term climate stability. Volcanic activity can both support and destroy habitability potential. Volcanoes release gases that help form protective atmospheres, but excessive activity may create hostile surface environments instead. Scientists examine geological features of exoplanets for similar activity. Magnetic fields remain another essential factor for protection. Earth's magnetic field shields life from harmful solar radiation. Without it, atmosphere would slowly erode into space. Many exoplanets may lack strong magnetic field protection systems. Stellar radiation levels influence atmospheric chemistry significantly over time. High radiation environments reduce probability of surface life survival. Some planets may still host underground or oceanic life forms. Subsurface environments provide protection from radiation exposure effectively. This expands possibilities for life beyond surface conditions alone. Scientists now consider multiple habitat zones on a single planet. Deep oceans, caves, and ice layers may all support life. Extremophiles on Earth prove life can survive harsh environments. These organisms live in deep sea vents and acidic lakes. Their existence expands definition of possible habitable conditions. Planets once considered dead may actually host hidden life. This changes how scientists evaluate distant exoplanets significantly. Atmospheric pressure also affects liquid water stability on surfaces. Too low pressure causes water to evaporate quickly. Too high pressure creates crushing conditions for organisms. Balanced pressure supports stable surface liquid water presence. Researchers model atmospheric evolution over billions of years. These simulations help predict long-term habitability potential. Star lifespan determines duration of habitable conditions available. Long-living stars offer more time for life evolution. Short-lived stars may not support complex life development. Planetary system stability depends on gravitational interactions carefully. Nearby planets can influence orbits and climate conditions. Chaotic systems reduce chances of stable life emergence. Astronomers also study asteroid impact frequency on planets. Frequent impacts may reset biological evolution repeatedly. Earth experienced such impacts in its ancient history. Some impacts may have influenced evolution of life itself. Understanding these factors helps identify promising exoplanets better. Each variable narrows search for truly habitable worlds. Despite challenges, discoveries continue at rapid scientific pace. New technologies improve understanding of distant planetary systems. Researchers remain hopeful about finding Earth-like environments. Every study brings us closer to answering life question. The universe still holds countless unexplored planetary systems. Human curiosity drives this endless exploration forward constantly. The search for habitable planets continues with strong hope. Scientists now expand search beyond traditional Earth-like assumptions. They consider many different types of potentially habitable environments. This includes ocean worlds, super-Earths, and tidally locked planets. Tidally locked planets always show same side to their stars. One side may be extremely hot, while other remains frozen. However, a habitable zone may exist in twilight regions. These regions could maintain moderate temperatures for possible life. Advanced climate models simulate such extreme planetary conditions carefully. Researchers test whether atmospheres can circulate heat effectively. Strong winds might redistribute heat across entire planet surface. This could allow life to survive in stable zones. Even unusual planetary systems may host habitable environments. Binary star systems were once thought too unstable for life. But simulations show stable orbits can exist in such systems. Stability depends on distance and orbital configuration of planets. Some planets may orbit both stars in wide orbits. These circumbinary planets experience complex but stable climates. Astronomers continue discovering such worlds using modern telescopes. Each discovery challenges previous assumptions about habitability limits. Atmosphere composition remains crucial for sustaining surface conditions. Thick clouds may regulate temperature and block harmful radiation. Clouds also influence rainfall and surface water cycles significantly. Water cycle stability is essential for long-term life sustainability. Evaporation and condensation processes maintain planetary climate balance. Without cycle stability, planets become dry or frozen quickly. Scientists also study planetary cores for internal heat sources. Internal heat may drive geological and biological activity underground. Radioactive decay contributes to long-term planetary heating systems. This heat may support subsurface oceans for billions of years. Even without sunlight, life could exist in such environments. This expands definition of habitable zones beyond surface regions. Life may not always require Earth-like surface conditions. Instead, hidden ecosystems could exist beneath ice or rock. Earth's deep biosphere supports life far below surface already. Microorganisms survive kilometers underground in extreme conditions. These discoveries changed understanding of life boundaries significantly. Scientists now expect life could adapt anywhere conditions allow. Adaptation is a key factor in biological survival across environments. Evolution enables organisms to adjust to changing conditions. Over time, life becomes more complex and resilient. Planetary age also influences chances of life development. Older planets may have more time for evolution processes. Younger planets might still be forming stable environments. Stellar radiation changes over time, affecting habitability levels. Stars become brighter as they age slowly. This may shift habitable zones outward gradually. Planets must remain within moving habitable zones long-term. Some may enter or exit habitable zones over time. This dynamic nature makes habitability more complex than expected. Astronomers use long-term models to predict these changes. Space missions continue collecting data from distant star systems. Each dataset improves accuracy of habitability predictions further. Artificial intelligence helps analyze large amounts of space data. AI identifies patterns humans might miss in complex datasets. This accelerates discovery of potential Earth-like planets. International space cooperation strengthens research capabilities globally. Scientists share telescope data across different countries worldwide. This collaboration increases chances of major discoveries significantly. Humanity continues building advanced tools for exploration daily. Each technological step brings new understanding of universe. The search for habitable planets grows more precise every year. New methods constantly redefine what we consider habitable. Possibilities for life in universe continue expanding endlessly. The cosmic search is far from reaching its limits. Humanity's exploration of habitable worlds continues with determination. As technology advances, the search for life becomes more precise. New telescopes can detect faint atmospheric signals from distant planets. These signals reveal potential chemical hints of biological activity. Scientists call these indicators biosignatures in astrobiology research. Oxygen remains one of the strongest potential biosignature gases. Methane combined with oxygen may suggest biological processes occurring. However, geological processes can also produce similar gas combinations. This makes interpretation of data extremely complex and challenging. Scientists must carefully eliminate all non-biological explanations first. Only then can potential life signals be considered seriously. Planetary reflection of light helps determine surface composition remotely. Ice, rock, and ocean surfaces reflect light differently in space. These differences help scientists classify exoplanet environments accurately. Space telescopes also measure temperature through infrared radiation detection. Temperature maps reveal possible climate zones across planets. Some planets show surprising Earth-like temperature distributions. Others appear completely frozen or extremely hot throughout. Cloud coverage can hide important surface and atmospheric details. Thick clouds make direct observation of planets very difficult. Despite challenges, new instruments improve clarity of data continuously. Future telescopes will capture even more detailed planetary images. These advancements may allow detection of surface oceans directly. Ocean presence is one of strongest indicators of habitability. Liquid water allows complex chemistry required for life development. Scientists prioritize planets with stable liquid water conditions. Some exoplanets may have global ocean environments entirely. Such ocean worlds could support unique forms of life. Life in oceans might differ greatly from Earth organisms. Evolution could take completely different pathways in alien environments. This increases diversity of possible life forms in universe. Planetary atmospheres also influence color and appearance from space. Blue hues may indicate oceans or atmospheric scattering effects. Red or orange tones may suggest different chemical compositions. Each color provides clues about planetary conditions and history. Scientists combine multiple observations for accurate planetary analysis. This reduces chances of incorrect conclusions about habitability. Machine learning algorithms assist in identifying promising exoplanets. These systems process vast amounts of astronomical data quickly. They highlight planets worth deeper scientific investigation immediately. Human researchers then verify AI-generated findings carefully. This partnership improves efficiency in space exploration research. Space missions are becoming more targeted and focused today. Instead of broad searches, scientists examine specific candidate planets. This increases chances of discovering truly habitable environments. Interstellar distances remain one of biggest exploration challenges. Even closest exoplanets are light years away from Earth. Traveling such distances requires technology beyond current capabilities. Therefore, remote observation remains primary method of study. Scientists rely heavily on indirect evidence for conclusions. Every new discovery refines search criteria further over time. Failed candidates still provide valuable scientific information overall. They help eliminate impossible conditions for life existence. This narrows down future targets for exploration missions. The search becomes more efficient with each passing year. Understanding habitability improves with every new scientific finding. Earth remains reference model for all habitability studies, but scientists remain open to unknown life possibilities. Universe may host life forms very different from Earth. These possibilities keep research exciting and unpredictable constantly. Each discovery brings humanity closer to answering life question. The journey toward understanding habitability continues without pause. Technology and curiosity drive exploration forward together strongly. Scientists remain hopeful about future groundbreaking discoveries ahead. The universe still hides many potential living worlds. The search for habitable planets is far from over. The final question remains whether Earth is truly unique in universe. Scientists believe billions of planets may exist within our galaxy alone. Many of these worlds could share conditions similar to Earth. Yet confirming actual life remains extremely difficult from vast distances. Habitability depends on perfect balance of many complex factors. Temperature, atmosphere, water, and energy sources must align precisely. Even slight imbalances can prevent life from forming entirely. Earth's success appears incredibly rare in cosmic perspective. This makes our planet extremely valuable and fragile. Studying exoplanets helps us understand Earth's unique stability better. Every discovery teaches us more about life's requirements. Scientists continue refining models of planetary habitability constantly. Future telescopes will search for stronger biosignature evidence. These instruments may directly analyze alien atmospheres soon. Such advancements could confirm existence of extraterrestrial life. Discovering even microbial life would change humanity forever. It would reshape science, religion, and philosophy globally. The universe would no longer feel empty or silent. Instead, it would become a living and dynamic cosmos. Researchers remain cautious but optimistic about future discoveries. Each mission brings new data and unexpected surprises. Space exploration continues expanding human understanding every year. International cooperation plays a major role in scientific progress. Shared knowledge accelerates discovery of habitable worlds significantly. Technology continues evolving at an extraordinary pace today. Artificial intelligence enhances analysis of distant planetary systems. This allows faster identification of promising exoplanets globally. Scientists now focus on most likely candidates first. This improves efficiency of space exploration missions greatly. The search is becoming more targeted and intelligent. Even small discoveries provide valuable scientific insights. Each planet studied adds piece to cosmic puzzle. Over time, patterns of habitability become clearer slowly. These patterns help guide future exploration strategies effectively. Humanity's curiosity remains the driving force behind exploration. The desire to understand life fuels scientific progress. Every generation contributes to this expanding knowledge journey. Future humans may witness first confirmed alien life. That moment would redefine humanity's place in the universe. It would mark greatest discovery in human history. Until then, exploration continues across endless space distances. The universe still holds countless unknown possibilities ahead. Some planets may already host simple life forms. Others may evolve complex ecosystems over time slowly. Conditions for life may exist in unexpected environments. Science continues challenging previous assumptions about habitability constantly. New discoveries often reshape established theories completely. This keeps astronomy an ever-evolving scientific field. The search for life is an ongoing global effort. Every telescope points toward new potential worlds daily. Humanity's understanding of cosmos grows deeper each year. We are only beginning to explore the universe fully. Endless mysteries await discovery beyond our solar system. Habitable planets may be more common than expected, or Earth may remain rare, unique exception. Only continued exploration will reveal final answer. Science moves forward step by step, carefully. Each discovery brings us closer to truth. The journey itself is as important as result. Humanity continues searching with hope and determination. The universe remains vast and full of wonder. Our curiosity pushes boundaries of knowledge endlessly. The search for habitable planets never truly ends. It evolves with every new scientific breakthrough, and humanity keeps looking toward the stars forever.